So basically any object thrown in space is a projectile. It follows the path of a parabola. The path that it traces is called as the trajectory. The vertical component, however, is affected by gravity. Okay, so AY is affected by gravity. So AY is given by minus G because this is moving upwards. The magnitude of acceleration at any point of time, the acceleration shall be given by limit of delta V by delta T as delta T tends to 0. Hello students, welcome to this third session on chapter 3, Motion in a Plane. I am Madhu R from the Department of Physics at Vidhyaashram PU College, Mysuru, your temple of excellence. Let us check what we had discussed in the previous session. In the previous session, we had obtained the expression for resultant of two concurrent vectors. Okay, we had resolved the vectors into its x-axis and y-axis components or rectangular components. Okay, we had also done two mutual components, two mutually perpendicular components of a vector. We had discussed about position vector, we had discussed about displacement vector, and at the end we had also seen what was the expression for instantaneous velocity as well as instantaneous acceleration. Let us check and further discuss these concepts in today's class. Let us check what is a projectile motion. After studying quite in detail about vectors, let us come back to the topic of motion in a plane or motion in two dimensions. What is a projectile motion? Any object thrown into space, it may be a shot put, it may be a javelin, it may be just a ball thrown into space, it may be a football kicked. All these are examples of a projectile motion. Okay, let us check. An object thrown into space with some initial velocity, because when you are throwing there is some velocity in it, with some initial velocity at an angle to the horizontal. Suppose you are kicking a ball which goes like this. At the point where the ball starts moving, the angle with the horizontal at that point, okay, is the angle to the horizontal. And this example shall give you what is a projectile. Any object thrown in space at some angle to the horizontal with some initial velocity is what is known as a projectile. As I told you, a shot put which is thrown, a javelin which is thrown, a ball which is thrown, a ball which is kicked, all these are examples of projectile motion. The path traced by this projectile, whenever a footballer kicks a ball, whatever path the ball takes, that path is called the trajectory. It is called as the trajectory, and this trajectory is a parabola. For all types of projectile motion, the trajectory shall follow a parabola. Okay, the velocity with which this object is projected is called the velocity of projection. Whatever initial velocity with which the projectile is moved, it is called as the velocity of projection, represented by V0. The angle between the horizontal, this is what we were discussing, the angle between the horizontal and the projectile. Okay, what is that projectile? Direction of the object to the horizontal drawn at the point of projection where the ball starts moving, that is called as the angle of projection, and it is represented by theta. Okay, so basically any object thrown in space is a projectile. It follows the path of a parabola. The path that it traces is called as the trajectory. Let us check further. Consider a body thrown up at an angle theta. Okay, you can check here. A body is thrown into space. It follows a parabolic motion. Let the angle with the horizontal be theta. Consider a body thrown up at an angle theta to the horizontal with some velocity. Okay, the velocity of projection can be resolved into two components along the OX line and along the OY line, or along the x-axis and along the y-axis. Okay, so we have got velocities V0 x along the x-axis and V0 y along the y-axis. In this condition, the horizontal component of acceleration remains constant. In the horizontal direction, there is no effect of gravity. So the acceleration remains constant, or Ax is equal to 0. No change in direction, no change in velocity. The vertical component, however, is affected by gravity. Okay, so Ay is affected by gravity. So Ay is given by minus g, because this is moving upwards. Okay, at the highest point, please observe, when the projectile follows this path and reaches the highest point, when it reaches the highest point, the velocity at this point shall be 0. Okay, the vertical component of velocity shall be 0. It moves, reaches the highest point, stops there for a while, and then follows the path downwards. So at the highest point, the velocity in the vertical direction remains 0. In projectile motion, please observe carefully, there are two parts. See, up to this point, where the projectile reaches the highest point, this is called as ascent of the object. It moves upwards, reaches the highest point, then it comes down back to the original place from which it was thrown upwards, from the level with which it was thrown upwards. The upward movement is called ascent and the downward movement is called descent. In motion in a plane, the time of ascent is always equal to the time of descent. So if you want to calculate the total time, you can calculate any one of these time and then double it up. Okay. Now let us check how the trajectory of a projectile follows a parabola in motion. Okay, let us prove that. Let us check one by one. Consider some body which is thrown up at an angle theta. A body is being thrown up at an angle theta with some initial velocity v0 to the horizontal. Okay. The velocity of projection can be resolved into two components along the x direction and the y direction. Okay. Along OX and OY respectively. What is it? Along the x direction it is v0 cos theta. Along the y direction it is v0 sin theta. This is v0y. This is v0 of x. Okay. So along the x and y axis, the horizontal component remains constant while the vertical component is affected by gravity. This is acceleration along the x-axis is 0. Acceleration along the y-axis is minus g. This is what we discussed in the previous slide as well. Let P be the position of the projectile after t seconds. So after some time, t seconds, okay, after t seconds, let the projectile reach point P, whose coordinates are given by x comma y. Okay, the horizontal distance traveled in time t. Okay, this is the horizontal distance traveled in time t. Let us check what it is. We know that x is equal to v0 x of t plus half ax t square. We know that ax equals 0. This is what we have said here. It remains constant. Acceleration does not change along the horizontal direction. Okay. Since the direction and velocity does not change, ax is taken as 0. So this term goes off. Along the x-axis, v0 of x is given by v0 cos theta. So x is equal to v0 cos theta into time t. If I take the inverse, t becomes x by v0 cos theta. Let this be equation 1. Let this be equation 1. Now let me find out what is the distance travelled in the vertical direction. Y is given by, once again, v0 yt plus half ax t square. We know that ay is given by minus g. So this equation becomes v0 sin theta into t minus half into gt square. Let this be equation 2. What can I do? For these terms of time t and t square, let me substitute the value of t from equation 1 into equation 2. What will happen? Y is equal to v0 sin theta into x by v0 cos theta minus half g. This was t square. X by v0 cos theta whole square becomes x square by v0 square cos squared theta. Okay. Now let us continue. This v0 and v0 gets cancelled off. This is sin theta by cos theta, which is tan theta into x. So this is tan theta x minus, okay, g by 2 V naught square cos square theta x square. I have x here and I have x square here. What does this equation look like? This looks like this tan theta looks like A, and this g by 2 V naught square cos square theta, let it be B. So you can find the equation to be like this: y is equal to ax minus bx square. Please remember that this equation represents a parabola. Okay, if you can recall, similar equation was y is equal to mx plus c, which represents a straight line where m is the slope of the straight line. Similarly, y is equal to ax minus bx square represents a parabola. So this equation we can conclude saying that the track followed by the projectile or the trajectory represents a parabola. Okay, therefore the trajectory of a projectile is a parabola. We have the proof saying that whenever an object is thrown into space, it follows the path represented by a parabola. Let us go ahead and check what is the time taken. Okay, we understood that the path followed by the trajectory is a parabola. What is the time taken to reach the maximum height? See, this is the point at which the maximum height is reached. Let us check what is the time required to reach that height. What shall we do? We know that V is equal to V naught plus AT, kinetic equation of motion. Okay, let us check what it is. In place of Vy, we know that Vy is 0. Okay, when you reach the highest point, the velocity becomes 0, and then the particle from this point, it starts coming downwards. Okay, so at that point the velocity remains 0. So this term becomes 0. Okay, we know that along the y-axis, V naught is said to be V naught sine theta. So I replace V naught y by V naught sine theta. Okay, minus gt, because the acceleration in the y-axis is influenced by gravity. Okay, so what will happen? 0 is equal to V naught sine theta minus g into Tm. Okay, where the time taken by the projectile to reach the maximum height is given by Tm. Ultimately, I can say that Tm is equal to V naught sine theta by g. By cross multiplying, I can obtain this equation. This time can be either for time of ascent, okay, or it can be for time of descent. Both are equal. So time of ascent or time of descent is given by Tm equals V naught sine theta by g. If I want to check what is the total time taken by the projectile to come back to its original level from which it was projected, it is twice the time of ascent or twice the time of descent. So I can say that time of flight Tf is equal to 2 times Tm. I have the equation for Tm, which is V naught sine theta by g. 2 times of that will be time of flight Tf is equal to 2 times V naught sine theta by g. These equations shall help us while solving the numericals. We have got a few more expressions to be obtained. Let us check what is the next one. The next one is the expression for maximum height. We have seen that at a time t, the projectile reaches a maximum height. Okay, it reaches a maximum height. I can call it as hm. I have to find out what is that height reached by the projectile. Let us check. Okay, y is equal to V naught y of t plus half into ay into t square. Going back to the equations that we have derived in the previous chapter. What do we know? We know that ay equals minus g, and V naught y along the y-axis is given by V naught sine theta. Let us replace those in this equation. It will be V naught sine theta, t is given by Tm. Okay, the time in which it reaches the maximum height is given by Tm. V naught sine theta Tm minus half g Tm square. What can I do? I can substitute for Tm from the previous expression that we have derived. Let us substitute. The distance traveled along the y-axis is already said to be hm. So I will replace y by hm. hm is equal to V naught sine theta into what was Tm? V naught sine theta by g. minus half g into v naught sin theta by g whole square, because it is Tm square here. Further, what do we get? We get v naught sin theta whole square by g minus half g into v naught sin theta whole square by g square. Why have I kept the g square separately? So that one g gets cancelled here. What is left? V naught sin theta whole square by g minus half into v naught sin theta whole square by g. This term v naught sin theta whole square by g is common. So what do? I take common v naught sin theta whole square by g as common. What is left? 1 is left here, minus half is left here. 1 minus half becomes half. So 2 comes to the denominator. So the expression for maximum height of a projectile is given by v naught sin theta whole square by 2g. Okay. Now, what have we done? We have found out what is the time required for the total flight of the parabola. What is the maximum height that can be reached? What else is left? We can find out what is the horizontal distance traveled by the parabola. I can call this as the range. Okay. So let me find out what is the horizontal range of the projectile. Once again, let us go back to the basics. Okay. The maximum distance traveled by the projectile along the horizontal direction is called as the range. So it is simply the distance along the x-axis. We know that x is equal to v naught xt plus half into ax t square. As we have repeated many times, along the x-axis, the acceleration will be 0. Okay. So displacement along the x-axis is given by x is equal to, what is v naught of x? It is v naught cos theta into t. Okay. Please remember that this time is the time required by the projectile to reach the final point. So it is time of ascent plus time of descent. So the time required here will be tf. So instead of x, I will replace it by range r, and the time required to be time of flight tf. We have already derived an equation for time tf. So let us replace r is equal to v naught cos theta into 2 v naught sin theta by g. What do we have here? I have got v naught into v naught, that becomes v naught square, 2 into sin theta into cos theta. Okay. What do we have? We have 2 sin theta into cos theta, which is sin 2 theta. Yes. So I replace 2 into sin theta into cos theta by sin 2 theta divided by g. This is the equation to find out the horizontal range or the maximum distance covered by the projectile in the horizontal direction. Now, the range becomes maximum. What is the maximum distance traveled? The range becomes maximum when theta is 45. What will happen if theta is 45? 2 theta becomes 90 degree, or sin 2 theta becomes 1. When sin 2 theta becomes 1, what is the remaining expression? Rm is equal to v naught squared by g. Similarly, for maximum range, I can also derive the expression stating that it is 4 times of the maximum height reached by the projectile. Okay. So please remember these equations. We will require them when we are solving some numericals. Okay. Let us move on and check another type of two-dimensional motion, which is a circular motion. What is this uniform circular motion? The motion of a particle along the circumference of a circle. Okay, so this body moves along the circumference of a circle. Okay, so motion of a particle along the circumference of a circle with uniform angular velocity. The angular velocity remains uniform throughout the motion along the circle. What is this? Let us check. When a particle moves along a circular path, whenever a body is traveling along a circular path, the line joining the particle, suppose the particle is here at position A, the line joining the particle to the axis. What is the axis? The center of the circle becomes the axis. So the line joining the axis to the particle is called the what? Radius, or it is also known as radius vector. the angle described by the radius vector. What do you understand by that? Okay, this radius vector travels some distance along the circumference from position A to position B in time delta t. Okay, so whatever is this circumferential travel that this particle has taken from point A to point B, okay, that is described by angular displacement delta theta. So this angle can be called as delta theta. For a small period of time, whatever is the angular movement of that radius line, that can be called as delta theta. Angular velocity is defined as rate of change of angular displacement or rate of angular displacement with respect to time, which is omega is equal to delta theta by delta t. So your angular velocity is given by omega. This angular velocity is definitely a vector quantity. It is expressed in radians per second. Okay, so omega is represented in radians per second. Let us check further how to obtain the relation between angular velocity and linear velocity. So I have to derive an equation for v and omega so that I can relate these two terms. Let theta be the angle subtended by the arc AB. So between these 2 points A and B, let theta be the angle. So the particle or the object has traveled from position A to position B along the circumference of the circle, and the angle subtended by the arc at the center OB theta. Angular velocity omega is given by theta by t. It is also given by 2 pi f, where f is the frequency. Okay, let us check. By definition, we know what is 1 radian. Okay, so theta in radians is given by the arc subtended by the radius. Okay, let the arc subtended be s and radius be r. Omega is equal to, for delta I am replacing that by s by r. What is s? S is change in position and t is time. Please recall the definition of velocity. Change in position with respect to change in time is nothing but velocity. So s by t has been replaced by v, r remains as it is. Omega is equal to v by r, okay, or v is equal to r into omega. V is equal to r into omega. So linear velocity is radius times the angular velocity. Okay, now let us check what is centripetal acceleration. Let us once again consider a particle or a body moving along a circular path. Okay, in uniform circular motion, the acceleration produced by the body always acts along the center or always acts along the radius of the circle through which the body is moving, and it will always be along the circular path. This is known as centripetal acceleration. This centripetal acceleration is also known as radial acceleration because it is acting along the radius of the circle. Consider a particle of mass m moving along the circular path. The radius of the circular path is r. Let r1 and r2, okay, please check. The particle moves from position P to position Q under some time delta t. Okay, within a time gap of delta t, the particle moves from P to Q. There is a change in position. Let r1 be the position vector at position P and r2 be the position vector at Q. Okay, r1 and r2 be the position vectors, and if you are drawing a tangent to this circle at position P and Q respectively, you will get the velocity vectors v1 and v2. So let r1 and r2 be the position vectors, v1 and v2 be the velocity vectors of the particles at the positions P and Q respectively. Okay, if you draw the tangents at P and Q, you will get the direction of the velocities. You can get at what direction the velocity is moving at any position. If you draw a tangent to the circle, you will understand the direction in which the velocity is acting. It keeps changing from position to position. Let delta v represent the change in velocity, okay, for a time delta t when the particle moves from P to Q. When the particle moves from P to Q, let the change in velocity be represented by delta V. The change in position is represented by delta R. Okay. Since the velocity vectors V1 and V2 are always perpendicular to the position vectors R1 and R2, the angle subtended by these change in velocity and position vectors delta V and delta R will remain as delta theta, because V1 is perpendicular to R1, V2 is perpendicular to R2. Delta V and delta R, the angles subtended, will be delta theta. Since all these are perpendicular to each other, the two triangles CPQ and GHI are similar. CPQ and GHI, these two triangles are similar. So I can compare the respective sides. What are those? HI by PQ equals GH by CP. What is HI? You can see that HI is delta V and PQ is delta R. I can replace HI and PQ by delta V and delta R vectors. Next, what is GH? Okay, GH is given by velocity, whereas CP is also the radius of the circular path. So I can take this as velocity by radius. What do I get? Delta V is equal to delta R by R into V. Let us resolve it further. The magnitude of acceleration at any point of time, the acceleration shall be given by limit of delta V by delta T as delta T tends to 0. As delta T tends to 0. Limit of the variation of velocity with respect to time. Velocity by time, rate of change of velocity by time will give me acceleration. So what do? I substitute for delta V from the previous equation. From the previous equation, what do I get? Delta V equals V into delta R by R. So I'll get this as V into delta R by R into delta T. Okay. So if I take the magnitude, I will get this as AC is equal to V squared by R. How do I get this? This is V by R. What is delta R by delta T? This is change of position. Delta R is change of position with respect to time. What is change of position with respect to time? Change of position is displacement. Change of displacement with respect to time. This will give me velocity. So centripetal acceleration is given by V squared by R. But from the previous expression, we know what is V. V is R omega. So replacing that, we will get this as AC is equal to R omega square. Because we have R omega whole square by R, I get this expression as AC is equal to R omega square. So what have we done? We have derived at an expression for this centripetal acceleration. Okay. Have a wonderful learning experience. Thank you.